What's going on, you guys, and welcome back to the channel. In this video, we're going to be looking at a web framework for the Golang language, and that's called Fiber. And if you're familiar with Express.js, then this may be very familiar to you, as it copies a lot of the patterns that are used there in this framework. Now, Fiber is extremely performant, and its performance is, I think, definitely blows the lid off compared to other APIs or web frameworks. And alongside Fiber, we'll be making use of Gorm. Now, Gorm is a ORM library for Golang. It's very popular. It just allows us to communicate with our SQL or SQLite database that we'll be using in this tutorial. Now, the other thing I want to mention is that when testing the API that we build, I will be making use of Postman, and you can download this at postman.com/downloads. I recommend using that if you have no other option. However, feel free to make use of curl commands or any choice of software that you see fit. The final thing is that when it comes to Golang or building web servers in Golang, there's no real or nice way of actually having hot reload in it. I think when it comes to Node.js development, you had NodeMon and other Python web frameworks. They ship with kind of hot reloading, or it's quite easy to add hot reloading to it. But with Fiber, there is a workaround, and I'll be making use of Fiber or this thing called Air, and that's this thing here. So you can go ahead and download this. I have a air.toml file, and that's in the GitHub repo that's for this tutorial, and that's all in the description below. But you can make use of this. Otherwise, this isn't, of course, this is optional, of course. You can just run your Go server as usual, but you would have to restart it every time you make a change. So whatever suits you, but I do recommend making use of this Air here. That's by Cosmtrek or Cosmtrek in this repository called Air, as it just makes development a lot easier. And of course, you wouldn't make use of this in production, but yeah. So let's first go ahead and jump into the directory that you want to build this API in. And let's create our module. So we'll say go mod init, and we'll just name it. Say github.com/ your username, and then the name. So I'll just call this Fiber / API. We now have our Go mod file. Next, let's go ahead and make the necessary installation. So go get. The first one is the SQLite stuff. So we'll say gorm.io/driver/SQLite. So this will just get the SQLite interface or API that we need when it comes to using Gorm. Next is actually installing Gorm itself. So go get gorm.io/Gorm. That will install Gorm. And lastly, just clear this. Let's install Fiber itself. So go get, and then github.com/ go Fiber /Fiber /v2. Now this v2 is important. This is the latest version of Fiber, and we'll be making use of that. So make sure you specify after Fiber /v2. Hit install. And that's our installations made. If you want to use Air, like I said, please feel free to go ahead and install this. Probably using these commands. You may have to, if you're using zshrc or any of your kind of bash files or your bash configurations, yeah, make sure you add that in there too. But it's pretty simple implementation or installation. So I'm going to go ahead and open this up in VS Code and just close all this. And like I said, when it comes to Air, again, this is not this This is optional, it's not required, but I'm going to go ahead and add this air.toml file. And I'm just going to go ahead and copy this air.toml file that I have in my repository. Just copy that and just paste it in, and that's it. So let's go ahead and create our main.go file, and let's get a very basic server up and running using Fiber. So I'm going to say new file, main.go, go, and the first thing that we want to do is just say package main, func main, and then let's get our app. So we'll say app, we'll say Fiber, and this automatically imports Fiber version 2. We'll say a new. Next, let's go ahead and actually add an endpoint to this. So we'll say app.get, and we'll say this is /API, and we'll call a function, and we'll say this is a welcome. This, of course, will return an error right now as we don't have a welcome function defined, but we'll get to that in a second. Finally, we can just start our app. So I like to kind of wrap this in a log, which will just print out the current status of our server. So whether it's starting up or closing, say app.listen, and we'll specify the port. So I'll say port 3000. So already it's very simple. We have our app up and running. Well, not technically once we've defined our welcome. So let's actually just do that now and then run this. So func welcome. Now this will take in a argument, and this is the context, and this will just be a pointer to fiber.ctx, which stands for context, and this will return an error. Now this context is basically everything that comes with a request, so your header, your body if it's a post request, all that. So that is what's contained in this. So to get this working, we can just say return c.sendString, and then we'll just write in a nice message. So welcome to my awesome API. So yeah, that's really it when it comes to getting a server up and running. Let's go ahead and run this. So new terminal. Now, if you're not making use of this air.toml, then you can just run this as you would any normal Go app. So go run and then just main.go, and you'll get this output here. So we can actually take this, copy this there, and then let's actually call it. So let's paste that in here. Oops. Hit send. And then we just need to put API and then send. And we get this message here. So this is in Postman, by the way, like once you have it open. So you have welcome to my awesome API. As it's a GET request, we can also just run that in the browser, and we get welcome to my awesome API. Nice. So that's our server up and running. And if you're making use of air, all you have to do is type in air, and there you go. And any change that you make, it will just reload it for you. But that's that for now. Let's just zoom out. Hopefully you guys can see that all right. Probably one more time. Anyway, so the next step is to actually connect our database up. Now this again is rather simple. It's not a lot, doesn't take a lot of line of code to actually get this working. So the first thing is let's create a new directory. We'll call this database. In that, we'll create a new file. We'll say database.go. This will be a package database. Now, the first thing is to declare a struct, which will just hold our database pointer. And this will be db instance, and then struct db pointer to gorm.db, and that is automatically imported. Next, let's create an object. So we'll say database, and then this will be of type db instance. And then we can say func connect db, takes no arguments and returns nothing. And let's call the Gorm to open up our database. So we can say gorm.open. And as we're making use of SQLite, type in SQLite.open, which again is automatically imported. And then within that, we'll say the name of our database. We'll call this api.db. You can name it whatever you want. Just make sure it ends with the extension .db. And then we can add our configuration. And as we won't be having any configuration, just throw in a pointer to gorm.config, and then just curly brackets, so the struct. Okay, so that's our first line for our connect DB. Next is to check if we get an error. So if there is an error, so if the error is not nil, then we can say log.fatal. We can say failed to connect to the database. We'll just add a new line and then error, and we'll just do a system exit of 2. Okay, that's if we get an error. If we don't, however, then let's print out that let's log out that you've connected to the database successfully. And then let's create a logger for our database. So this is just logging information out. It's just printing stuff to the command line. And this will just be logger default and then .log mode. And we'll say logger.info. So just to add some nice colors, etc., and to know the state of our database. Next, we'll say log.println, and we'll say running migrations. And we'll get to the actual migration part in a second. So we want to add a to-do, so we'll come back to this, add migrations. That's because when we open up, so let's say we start this from the top where we don't have our database just yet. What will happen is it will create our api.db or create our SQLite database. However, it will just be an empty database. There'll be no tables in there. So we'll be building an API that basically holds users and it holds products, and a user can then make an order to that product. So very simple. We won't be making it too complex. But we want all of those, so the users, the products, the orders, to kind of be added, so those tables to be created in our database. And that's what we'll do underneath this to do. But for now, let's go ahead and set our database. So we'll say database. So this database struct here. And this will be a DB instance, including DB, and then just DB. So the database that we get back from when we call gorm.open. So that's really it. I mean, like I said, with these migrations, also, if you're familiar with Django or Prisma in JavaScript, then yeah, it works just like that. Now, to actually create our tables, let's go ahead and create a new directory. We'll call this models. In that, let's first create a model for our user, so user.go. Now for this, it's very simple. First, we'll just state package models. Then we'll create our struct, and a struct, the struct that we create here is just a representation of our table. It's just the Golang representation of it. So type user and then struct. Oops. Now we want the ID, which will be an unsigned integer. And then in backticks JSON, so how it will look in JSON format, so it'll be lowercase ID. And then to tell Gorm, we want this to be a primary key for this table. Next, we want a created at, and this will be time.time. And by saying like this, it will automatically create this. And then first name, which is a string, backticks JSON, and in double quotes, first underscore name. Next is last name. this will be JSON representation as last name, like so. So that's our user. Next, let's go ahead and create a product model. Again, package models, just to make sure this is models. Yep. And we'll say type product, and then struct. We'll have the ID, which is unsigned integer. Oops, int. And this will have a JSON representation of ID. And as for Gorm, we'll just say this will be a primary key. And make sure the spelling is correct and in camel case. Next, we'll have our created at, and this will just be time.time. And we'll have the name of the product, which is a string. In JSON, we'll just say lowercase name. And then let's just give it a serial number. JSON serial underscore number. That's really it for our product. Lastly, we just want to make use or create our model for order. And this will have some foreign keys. So this is where it gets interesting for Gorm. We'll say package models, and then type order, struct, and this will have an ID. So I'm just going to go ahead and copy these two in order to not repeat myself for the third time. And then we want a foreign key for the product and a foreign key for the user. Now to do that, we want to create something like a product referrer, and that will be an integer as it's just an association with the ID in the other table. So the product here will be associated with this ID here. And we'll say here that this is in JSON representation, just the product underscore ID. Next, we want the actual product itself. And as this is SQL, we cannot actually, there's no SQL type for the product struct that we defined here. That's why we need this product referrer. So here we can just say Gorm and then foreign key and then colon product referrer. So it's saying, okay, the product here is going to be referenced by this product referrer, which will then look inside our product table and then fetch the product that has the ID that matches this product referrer here. So that's our product. Next is our user referrer, and this will be of type int, JSON, user underscore ID, and then our user, and that will be in backticks Gorm foreign key user referrer. So yeah, these are our models. So we have our user, which is very basic, has the ID created at time, first name, last name. Our product, which again has ID and created at, a name for the product and a serial number. And then the order itself, which is ID created at, it holds a product and it holds a user. Now let's go back to our database.go, and this is where we'll add our migrations in. So to do that, all you have to do is type in db.auto migrate, and then just pass in the models themselves. So the first one will be models.user. So the struct there, a pointer to it, of course, with this ampersand. Then we want the models.product. And lastly, we want the order. So now when this runs, let me just get rid of this to do. When this runs, it will create the tables for a user, models, and order. Now, before we actually go ahead and run this, One thing, if you are using VS Code, then one extension that I find very handy is this here, SQLite. And what this does is it just allows us to have like a nice visual representation of our database inside VS Code, so we don't have to query it all the time. So yeah, feel free to go ahead and install that. And if you have installed it, then what you can do is, actually, let's just run this quickly. So just clear it. I'm going to type in air to use the hot reloading. Let's give it a second to start up. Any second now. Yeah, okay, yeah. So one thing I forgot to do is actually call this connectDB. So back in our main.go, we need to do that. So we can say database, which is automatically imported, and then .connectDB. That's it. So I forgot to do that. Sorry. Let's just zoom in, type in air, just building it, running. And here we can see that it's creating our table orders. It created the table for products, and it created our users table. So you can see here in the file explorer that we have this new file now called api.db. If you have this extension that I just mentioned, you can right click it and say open DB or open database. And down here, you'll see the SQLite Explorer. You can open that up and you'll see now that we have orders, products, and users. So that's what this auto migrate does. It takes our structs, creates a table out of it in our database. And yeah, that's pretty much it. It's quite simple. It's quite elegant to do as well. So I'm just going to close that, but that's really it for our database. Now we can actually get started with creating our API endpoints. So to get started with our API endpoints, the first thing I'm going to do is create a new directory in our project, and I'm going to call this routes. Within that, I'm going to create a new file, and this is going to be user.go. So all of the endpoints in here are going to be related to the user. So creating a user, reading a list of users, updating and deleting. So let's go ahead and write package and then routes. And the first thing I'm going to do is, let me first just go ahead and close all of these and just leave the main.go and the user models file open. So I'm going to go ahead and create another version of user, so another struct for user, and I want to have the ID, the first name, and the last name. And the reason I'm doing this is from what I understand, is that it's a good way for readability to kind of separate the model from and this will be more like our serializer. And it's quite nice how you can do this in Golang. So I'm just going to say user, and then this is going to be a struct. It's going to have an ID, and I don't want to have the created at. I'm not really interested, so I'm going to leave the created at part out, but it's going to have the ID. This is going to be an unsigned integer, and we'll just give it the JSON format of just ID in lowercase. Next, I'm going to have the first name. This is going to be a string, and the JSON field name for that is just going to be first underscore name. Then last name, string, JSON, and then last underscore name. Now you can see how similar it is to the user model. I've just separated it out as it's just easier to kind of use this as our serializer, if you're familiar with serializers when it comes to RESTful APIs. So I'm just going to leave a comment to say that this is not the model user. See this as the serializer. And you'll see why in a second. The next thing I'm going to do is actually create a function that will create this so we don't have to keep on building a struct by hand. And what this will do is a create response user. And this will take in a user, but it will be a model. So from models.user. and this will return user. So it will take in the user model struct as an argument, and it return this user struct here. I mean, I could change this as like user serializer if I wanted to, but it's fine to just leave it as user here. But you can go ahead and name that if it helps. So this will just return a user struct. Now it would be, if we were to do models, then we'd do models.user, but we actually want to use this struct here. So what we can do is just say user, then we can pass in the ID as being this user, so this one here. Actually, it might be best to just name this as user model. So this will be user model.id. We'll have the first name, and that will be user model.firstname, and then a last name, which will be a user model.last name. And now we'll use this as our helper function when we create our endpoints. So the first endpoint I want to create is one for creating a user. So we'll say func and then create a user. And here we'll just say we'll create, just like we did in main.go, so the beginning of the video where we created our welcome. So we'll have this context pointer, so fiber.ctx. And we can just do that here. We can say fiber, hit enter, so it automatically imports it, .ctx, and this will return an error. So all endpoints, all endpoints that we write in using fiber will always return an error. So the first thing is let's create an empty variable or object of models.user. And then let's go ahead and look at the body of our post request. So we can say if the error does not equal c.body parser, and then we can just pass in a pointer to user. So this user variable here, and then we can say if we assign error to the value here. So if we get an error back from that, so if it's not nil, then we can return an actual HTTP error. So status, set this as 400, and we'll just say that the error is error.error. So what this does is whatever we pass in our request, it will map that input to this user, so the model instance in this case. We're not doing any other form of validation. I mean, you can put in as many fields as you want. There are other libraries that help with validation, but I'm not going to cover that in this video. For this, it's just going to make sure it'll just map like the first name to the model first name, the last name to the model's last name. The ID doesn't matter as that's automatically generated. So when you're creating a user, you don't actually pass in the ID, or you don't put that in the body post request. Next, we'll say database. So that will automatically be imported as well. We'll say database.database.db. So our actual database instance, and then we can say create. And this just creates an object and then saves it into the database, and we'll pass in our user, so a pointer to our user, so ampersand user. Next, let's create our response, and we'll just say response user, and we'll call the create response user, and from there we can just pass in user. And then finally, we can return that response user. So we can say c.status, first of all, just to say that it's successful, status 200, and then we can JSONify our response user. So that's it. That's our create user endpoint. We can go back to main.go and actually add this in. And what I want to do in main.go is actually create a function that will set up all our endpoints. So we can say func setup routes. So setup routes like that. It will take in the app, which is a pointer to the fiber app. It will not return anything. So we first have our welcome endpoint, which we can just say as app.get, and we can just add in /API and then just welcome. Next, we'll have all our endpoints for our user. So user endpoints. Say app. First of all, we have a post one, so we'll say /API/users, and then we'll say call routes. Did I name it routes? Yes, routes dot create user, like so. Now down here in our main function, we can say, or we can get rid of this, and we can just say set up routes and just throw in the app. Cool, so now we have our two endpoints. We can go ahead and test this out. So back in Postman, I'm going to say users. We cannot get anything. Actually, on top of that, I don't think this server is running anyway. So I'm just going to type in, you can do go main, go run main.go, or if you have the kind of hot reloading, just type in air. So just give that a second for it to build. Okay, so yeah, it's running successfully. Now I can go ahead and do a post. So switch that to post, and then in the body, let me just shrink this. The body, we want binary. It's odd that it's so zoomed in for some reason. Let's see if I can zoom out a bit. Yeah, so binary post. Oh, raw, sorry. So go into raw, and then just set this to JSON. And we can say first name. We'll set that to Harry Potter, or just Harry, and then last name. We'll set that to Potter. If we send that now, we get back our ID1, so that's automatically created for us, like Gorm handles all that. We have our first name and our last name. So now if I go back and if I run the database, so if I open database using the extension, just close that. If I open this, if I click play on users, then I can see here in the right that I have the ID, which is 1, the created at, so the exact time in which it was created, and then first name and last name. So that's it for creating a user, which is fairly simple. We only wrote a few lines, and yeah, worked out fine. So next, I'm going to go ahead and create another endpoint, and this endpoint will get all the users in our database. So we'll say func get users, so plural, C, and then asterisk fiber.ctx. And this, of course, will return an error. Okay, so the first thing is that we want a list of users from our database. So what we can do, similar to what we did here, apart from we want to specify that it being a slice rather than a single object, we can say users, and then we will say square brackets, models dot user, and then curly brackets. Next, we can query the database, so we can say database.database.db.find, and we can pass in the users variable that we have here. And notice that what we're doing here is actually we're taking this empty users slice, and then we are throwing it into this function here that looks for all the matches, like Gorm handles all this under the hood, which is very handy, as it's just saying, okay, find everything that matches with this user model, throw them into this users. So now we technically have a list of users. And next, we can go ahead and say that the response users is going to be a list of this user struct here, so our serializer. So a square bracket, user, like that. And now we can loop over each of our users that we get from our database, and we can kind of create our response, call this create response user, and then chuck them into this slice here. So we can say for, and then underscore, because we don't care about the index, we'll say user, we'll say range over the users. So for each iteration, what we want is to create our response user, which will be create response user, throw in user, response users. So our list of our users that we want to return, we will say append response users. So that just autofilled it for me, and then just pass in response user. And then finally, we can do return c.status 200 and JSON and then response users. So that's our get users endpoint. We can go back now to main, and in our setup routes, we can say app.get, and it will be the same endpoint as the one before. So API users, we'll say routes.get users. So as I've got air running, it just reloads it for me. Again, if you don't have air, if you don't have this hot reloading function, then you can go ahead and just run. You have to restart the database and type in go run main.go. But I'm going to go back now to this. I'm just going to go ahead and actually save this in a collection. I'm going to call this fiber Gorm in this collection here, just so it's just easier to kind of find these later on. And this is create user. Just save it. Okay, let's open up another tab, HTTP API users. This is just a GET request, send it. We get back a list of users. As we only have one, we get Harry Potter. So let's create another user and see if we can get back more than one. Say this is John Doe, send it. So now we have our response in our create user. And if we go back to our get users and we call this now, we get back two users, we get ID, we get John Doe and Harry Potter. So I'm just going to go ahead and save this again now and call this get all users. Save it. So yeah, that's that one. Let's go ahead and create a few more. So we want to get back individual users. Now to do that, all we need to do is first of all create a function to just get user. And this is where it will get a bit interesting compared to the last few endpoints that we created. So as always, pass in a argument or a parameter of context, which is a pointer to fiber context, and then it will return an error. And when it comes to a individual user, what we'll do is actually add another / after users and then specify the ID. So maybe 1 or maybe 34. And we want to grab that ID. So in order to do that, just say ID and error is going to be set to c.params. As it's an integer, we can say params int, and we'll be looking for ID. Next, let's create our user. So var user and then models.user. And let's check to see if we get an error back first. So if we don't actually pass an integer, so it will raise an error then. We can say if error does not equal nil, then return c.status, pass in 400 as the error, and then JSON, we can just put something like, please ensure that, say, ID is an integer. Next, we can go ahead and actually fetch our user. Now, to do that, we're going to go ahead and create a helper function, and this is going to be called find user. It will take in an ID, which is an integer, and it will take in the user pointer that we want to set this to. So it'll just be models * models.user, and this will return an error. And here we can say database.database.db and then find. So just like we did in get users, we did this find and then a list of or a slice of users. In our case, we don't want a whole list back. We want to filter it based on the ID that we pass in. So we can just say something like we want the user, ampersand user. We can set the query, so we can say where ID equals and then question mark, and we can say the question mark will be filled in by the ID itself. Next, we can say if the user does not exist. So all IDs begin with 1, so they can never be 0. So if we have user.id, if that equals 0, then we'll return errors.new, and then we'll just say user does not exist. And then finally, we'll just return nil. Okay, so down back at our get user, we can say so we can call this, we can say if error and then set that to find user. We can pass in the ID and then the user itself, which is a pointer, so ampersand user. We say if then have our conditional error does not equal nil, then we can just return c.status, say that's a 400, and JSON, and we can say error.error like that, as that error will just be user does not exist. So okay, if that all passes, then we can say the response user is going to be create response user and then just the user. And then finally, we can add c.status, pass in 200, and then JSON response user. So what's happening is when we do this find user, we're passing in this user variable here. So as a pointer in here, it will query for that user. If it exists, it will then associate whatever it finds with this user variable. That's why we can do this create response user, as this now has a variable. If it didn't, then we'd get an error back and we'd get the message status of 400 along with our message saying user does not exist. So let's go ahead and add that. We can go ahead and say here app.get, we'll say / API users and then / ID and then roots.get user. So this ID here, this ID part after this colon is what's read here on line 57, params int find ID. And we can go back now to Postman. We can make a request, so HTTP users, and then pass in the ID. So we know 1 exists, and we get back Harry Potter. If we do 2, we get back John Doe. Now, if we try something like 3, send, we get user does not exist. So all working fine, and we also get the status of bad request. And let's go ahead and save this. We'll say this is get single user. Save it. And yeah, so let's now move on to our update, which takes in a bit more. So what we can do is say func and then update user. This again, we'll do the fiber.ctx, return an error. And let's do what we did here. So we can take actually a couple things from this. We can take all that. Actually, I think we can take all of this, to be honest. So from the ID params int all the way to find user, the whole if statement there. Let's paste it in. So we're getting back our error. As we want to update our user, we need to actually fetch our user. So what we can do now is create our struct. And remember, we cannot edit. We don't want the user to be able to edit the ID. The ID is set by the database. It's something the user should never really care about. They can only change their first name and their last name. We can say update user. We'll set this as a struct. And this will just have the first name string. And we'll say JSON fast, double quotes, fast underscore name. And then we'll just add another one. So last name, we'll say last underscore name. So yeah, that's our update user struct. So we only want the user to change their first name and last name. What we can do now is create an instance of this struct. So var update data will be update user. Next, we can go ahead and pass it. So we can say if error does not equal, or if error, so set error to c.body parser, not body, but body parser. And we can pass in the pointer to update data. If the error is not nil, so if there is an error, we can just say return c.status, give this a status of say 500, and JSON error.error. So if this all passes, then we have our update data associated with this. So we have first name, last name. So now that we have that, all we need to do is say user. So the user that we get back from our database when we do this find user, user.firstname equals update data.firstname, user.lastname equals update data.lastname. And then finally, we can save this. We can say database.database.db, save, and then just pass in a pointer to our user. So that's now successfully updated it. We can then just create our response user by saying response user is going to be create response user, and we can just pass in the user model itself, and then just return c.status of 200.json, and then pass in response user. So yeah, that should be our update. So we can go back to our main.go file. In our setup routes, we can say app.put and /API/users, and we want the ID included as well. And we can say routes.update user. So now once that's built, we can go back to Postman, create a new tab, HTTP users. Let's do Harry Potter. So this is going to be a put request. In our body, it's going to be raw and it's going to be JSON. We can say that the first name is going to be Larry and the last name is going to be, let's just say Snape. Okay, so let's send that. And we get back ID 1, so where Harry Potter was once ID 1, we get back first name Larry and then last name Snape. If we go to our get all users, we send now, we get Larry Snape rather than Harry Potter. We can also do single user at ID 1, so send, and we get back Larry Snape. So updating is successful. I'm just going to go ahead and save this tab, call this update user. Cool. So the last endpoint for our user is going to be the delete user. And for that, let's go back to our user.go for routes. And we'll say func delete user, c, the pointer to fiber.ctx, and then error. And again, we can kind of pretty much copy what we have in this here. So we can take that. Actually, we can take all of this again. So we get back a user if it exists. So and that's set to this user here. And then what we can do is actually delete it. And with deletion, it could return an error. So to do that, we can say if error equals database.database.db.delete. And then we can pass in our user. So we want to delete this individual user. The error does not equal nil. So if we get an error back, then we can just say return c.status, and we can set this to a 404.json, and then we say error.error. Otherwise, we can just send back a message that basically says or return c.status 200, and say send string successfully deleted user. So that's our deletion. We can go to our main.go file and we can add that in. We can say it's pretty much the same as this, apart from instead of put, it's going to be delete. And then here we'll just say delete user. So just wait for that to rebuild. Head back here, let's create a new tab, HTTP, users, let's delete Larry Snape. So we'll send that and we get successfully deleted user. So if we go back to get all users, send, we don't get Larry Snape anymore. So yeah, that's our deletion. So that's really our user endpoint. So it covers all the basic CRUD stuff. In the next part now, we'll just go ahead and create our order routes. So just not our order, our product routes, which is very much the same as our user. And then our order one, which will take into account our foreign keys. So for our product endpoints, we're going to be doing something, well, pretty much what we've just been doing for our users. So in our routes directory, let's create a new file and we'll call this products.go. And for that, the first thing that we need to do is actually state the package name. So package and then routes. And then let's create our product struct. So pretty much like our serializer that we did for our user. And for this, we want the ID, which is going to be an unsigned integer. And we want the JSON, which is going to be just ID. Next, we want the name of our product, which is a string. JSON for that, we'll set that as just name, but lowercase. And then finally, our serial and number, string and JSON, in backticks, so JSON and serial underscore number. So yeah, that's our product serializer. Again, treat this like a serializer. This is not the model. And down below, we can add our create response products. So func create response product. This will take in a product, so product model, we'll call it. And this will be of models.product. And then this will just return the product struct that we just defined over here. And all we can do here is just say product. This will have the ID of product model.id. We want the name, which is the product.name. And then we just want the serial number, which is product.serial number. Okay, so let's create our first endpoint, which is to create a product. Again, very much the same as our create user, so I don't really want to repeat too much for the sake of time. So ctx, return an error, and then we'll say var products and then models.product. We will do if there is an error, so set error to c.bodyparser. We will throw in our product, so a pointer for that, and then if there is no error, obviously this will then become this will be set to our product variable or object here. If there is an error, then we want to deal with that by saying return c.status with a 400 and JSON being error.error. Next, we'll just say database.db.create, and we'll just pass in our product. So product like so. And then we can say the response product is create response product, and we'll just pass in our product. And then finally, we can do c.status 200, and then JSON, we'll just say response product. So that's our create product. Let's go ahead and add this now in our setup routes function in main.go. So we'll say product endpoints. Say app.post. This will be /API/products routes dot create product. So once this is reloaded, we can go back. Let's just save this one here. We'll call this delete user. Let's create a new file, a new tab, HTTP, instead of users, let's do products. We'll do a post. This takes in a name and a serial number. So as JSON, we can say the name, which is going to be, say, Ben and Jerry's cookie dough ice cream. The serial number, we'll just say serial underscore number, and we'll just put in a bunch of random numbers, send this, and what we get back is the ID, name, and serial number. Okay, so again, very similar to how we did users. Let's go ahead and do our get products. So here we can say func get products, C, and then asterisk fiber.ctx error. And this will have a list. So products, or slice, sorry, we'll say models.product. So a slice of product structs from models, database.database.db, and then we'll find them. So find all the products and then associate with them products. The response products will be a slice, so response products, a slice of our product struct. And then let's loop over them. So for and then product range, and then over our products. And we'll say our response product is going to be create response product. We'll pass in our product. Then we will add that to our response products. So append response product. Oops. There we go. Just get rid of this bracket there. And then finally, we can just return c.status 200, and then just add JSON, and then our response products. So that's how we get products. We can go back and add them all in a second. Let's just add our endpoints in first. So just like we did with our user routes, we had this find user function, or this helper function that we created, this find user. We can do the same for product. So I'm just going to copy that, go back to products, paste that in. Instead of find user, we'll say find product. This will take in our product. Instead of user here, we'll just call this product. Then we'll have product here, then product ID there. And then as our error, we'll say product does not exist. Oops. Cool, so that's our find product. We're getting a warning as it's unused, so let's go ahead and use it. So for our user.go, we did our get user. We can do the exact same. Let's actually copy this and then just change it for our product. So we'll say get product, and all this is fine. This is going to be product, and we'll say models.product. So this part's fine. We'll call, instead find user, we'll say find product, and we'll pass in our product. Create response, this will be product. And create response user will not be, instead be create response product. And that's about it. So yeah, that's how I get product. Again, we'll add this in a second. Let's just add in the rest of our endpoints, because this is somewhat of a repeat of what we've already done with users. So our update user, actually let's copy in both update and delete. So just down here. So for our update user, instead we'll say update product. And for that, we pretty much have everything in place. We just need to change some stuff. So models, product. This instead will be product. Find user will not be the case. We'll have find product. And then for our update user, instead of update user, we'll have update product. And then we'll have name, this here being name, and the serial number. So just serial underscore number. And instead here we'll have update data, but this will be update product, so this struct. And then, so this is all fine. Instead of user here, we'll say product, and then we'll just say name is set to the update data name. Here we'll have product. Instead of last name, we'll have the serial number, and the update data will have the serial number. And then we save our updated product. We create a response. So create response product. This will be a product. And there we go. So that's our update. Now we can look at our delete. Instead of delete user, we want delete product. And again, product. We will call find product, pass in the product. Then here we'll say delete the product itself, and successfully deleted product. So yeah, that's our endpoints now for product. We can go back to main.go and let's add them in. So we'll say app.get, and this will get all of the products. Routes.get products. Then we'll have our products for our single product, so ID, and instead we'll have get product. Then we'll have our put, which will be, instead of get product, we'll have update product. And then finally we can just do delete. So /API products, and then colon ID, routes dot delete product. So let's go ahead and test all of this out just very briefly. So back here, this is our, let's just save this as create product. And let's actually go ahead and create another product so we can have a few to mess around with. So we'll say, instead of Ben and Jerry's ice cream, we will say Air Jordans. Give it a code, send. Next, let's give it something else. We'll say MacBook, give it a code, send. So let's go ahead and first test our get all products. So our products here, send, and we get back all the products. Let's just save this as get all products. Add another one, so this will get back an individual product. So we'll say /1, so the one with ID 1, we get Ben and Jerry's cookies. Let's say 3, we should get back MacBook. If I try a different one, we get back product does not exist. So cool, that works fine. So we'll say get single product. And just for the sake of it, let's test our put. So HTTP products, say our first one, so our Ben and Jerry's one. Let's change this so that it will, as it was cookie dough, let's change the flavor of it. So we'll say name, we'll say Ben and Jerry's brownie. We'll change the serial code of it as well. So serial number actually, and we'll just add something else, send it, and we get back ID 1. So before it was the cookie dough, but now it's Ben and Jerry's brownie, and we get back our new serial number. that works fine. Let's just save that. Update product. Let's add another one. So I'm just going to close some of these tabs just to make some room. But let's delete something. So this is going to be a delete. It's going to be a product. So our first one. So this is now Ben & Jerry's brownie. Let's send it. And we don't get anything back because, did I write it in right? Products. So I put product. It should be products ID. Let's try that again. Just wait for it to build. Send it, and we get successfully deleted product. So all good. And if we actually go back and get all the products, so get all products here, send, we just get back IDs 2 and 3. So that's it for when we want to, so all the CRUD stuff regarding our product, again, very similar to our user. So our user roots, so apologies if it seemed quite repetitive. But the next part is to create our roots for our order. So when creating an order, reading an order, etc., we will not be adding update and delete because I think from a domain perspective, it wouldn't make sense to update or delete an order, maybe. I mean, depending on the kind of order you may want to update it. But also it'd just be very repetitive of what we've done already. So yeah, we'll just focus on actually like handling these foreign keys, etc., and how we would work with that. But yeah, so let's go ahead and create our order routes. So for our orders endpoint, let's create a new file within our routes. We'll call this order.go. And as before, let's first of all set our package. So package routes. And then let's create our like struct serializer. So type order struct. And then we'll have our ID, which is an unsigned int. And this will have the JSON in backticks. So just lowercase ID. We'll have the user, and we want to, the way in which we want our order to look. So for our endpoint, I'm just actually gonna just comment it up here, or just, yeah, just write it quickly like this. So we'll have our ID, which is going to be something like 1. Then we'll have our user, and this is going to use the user struct that we built in here. So this guy, let me just shrink this. So this struct here, so we'll have the ID, first name and last name. So ID like 23, the what is it? The first name, which could be, say, Bob Marley. Oh, Bob, and then last name like Marley. And then we'll also have the product that you ordered. This will just look like, I mean, ID 24, say the name is a MacBook, and the serial number to be, add something like that. So this is what we want our serializer and like in this kind of format. So let's continue. So user, so the user struct that we defined in our user root, so not the user model. This will have a JSON of user. Then we'll have our product, and again, so product, the one that we defined in our product roots, and the JSON product like that. And then finally, we'll have our created at, and this will just represent the time in which the order was placed. So time.time, and we'll write this as order date. Cool. So again, let's create our create response order, and this is going to be slightly different. So create response order. What this will take in is first the order, which is going to be of models.order. Then it's going to take in user, which is a object of our user struct from our user roots, and then product, which is going to be product. So this is just going to return order. And so we can just say order and then ID, which is just order.id. And then we can also add the user. So user, which is just the user that we pass in here. We want the product, which is just the product, like that. And then finally, we can just add our created at as well. So we can say created at, which is order.created at. And that will just be our order date. Cool. So let's do our create order first. So we'll say func create order, and we'll say c asterisk fiber dot ctx. This will return an error. And what we'll do first is actually get our object. So var and then order models.order. First, let's do our check. So if the error, so set error to c.body parser, we'll pass in our order. So map all the input that we do to this model instance. And if there is an error, then we'll just say return c.status of 400, and then the JSON, which is error.error. Cool. So that's that one. And I know we're not doing a lot of validation at all. Well, not really a lot of validation, but for this, we want to make sure that the user that we associate with our order and the product that we associate with our order, that they both exist. So we can do that quite simply by saying the error will be set to find user, and this will take in the user referrer that we get from our body, from our request, and we'll pass in our user our object, which we need to create up here. So we'll just say user or var user and then models.user. And then back here we can say the error does not equal nil, then return c.status 400. In fact, let me just copy this. Yep, so that's our user. So if we get back an actual user that actually exists in the database, then we'll continue onto the product and we'll just do the exact same thing as we did with user. So models.product, and we'll just copy all of this. And we'll replace find user with find product, order.product referrer, and the product. And that's about it. That's pretty much our validation. What we can do now is actually create our order and add it to the database. So database.database.db, create, we'll pass in a pointer to our order. And then let's get our response user, which is going to be create response user. We'll pass in our user. We'll say response product, set that to create response product, throw in product, and then response order, which is just going to be create response order. We'll pass in the order itself, so the model instance, the response user, and the response product. Oops. And then finally, we can just return c.status of 200, and then JSON response order. Let's go ahead and test this out now. So as soon as it's built, so we have, let's first go ahead and check what we have. So get, let's save some of this stuff. Oops. What was this? So this was actually delete product. Okay, close that. Just close all of this. So this one actually we can call, so we can say get all our users. So we have one of ID 2. We can use that user. And so we can also just get our request as well. So get all products. What products do we have? What IDs? So 2. So we'll say that John Doe has ordered a pair of Air Jordans. And actually we just need to add this to our main.go. So we'll say order endpoints app.post, say /API, and then orders routes.createOrder, and back here, let's go to the endpoint. So HTTP API orders. This is going to be a post. We have the body. Set this to JSON. So first of all, we need the user underscore ID. So user underscore ID. And notice that we're not putting user referrer. That's because so here we just put like user and product. Oh, not here, sorry, in the actual model, because we map it against the model itself. So there's var order and then body parser. We actually pass in a pointer to the order model. So we have this product referrer, which is just product ID and user ID. That's why we set it as that here. We'll set the user ID to be 2, so John Doe, and the product ID to be, I think the Air Jordans is also 2 as well. We'll set that to 2. Send that, and we get back the response, which is our order, so ID of 1, the user, so John Doe, the product, Air Jordans, along with the serial number, etc., and the order date, so the time and date in which it was ordered, which is nice. So we can now create an order. Let's create something so that we can get all of our orders. So down here, we will say get orders. So func get orders, and it will say this is fiber.ctx. It will return an error. And so we'll say orders is going to be a slice of models.order. And then we want the database to find all of our orders. So pass in ampersand orders. And then we'll have our list of response orders, which is going to be a slice of order. So we'll loop through. So for order, range over orders, and we'll say var user, and then this is models.user. We want the var product, models.product, because for each order we need to fetch both the user and the product. So then let's do a database query. So database.db and then .find. We'll pass in our user, the ID, so ID equals question mark, and the orders user referrer. So we'll do order dot user referrer, which is actually the user ID. So we can pass that in, and that will then find a user of that ID and associate it with user if it exists. And we'll do database.database.db find, and we'll do the same for product, where the ID equals order.product referrer. So now we have both the user and the product. Now we can create our response order, which is going to be create response order. We need to pass in the order itself. We need the user that we created here. And then we also need the It's interesting that we need the response. So create response user, we can just do it inline like this, and create response product, which will also be product there. So now we have a response order. We can then append it. So response orders, append, and then add in the response order. And then finally, we can just say return c.status and then 200 and then .json response orders. So back in main.go, we can add this. We can say app.get /API orders routes.get orders. Let's wait for this to rebuild. Now back over here, let's just save this as create order. We can call HTTP orders. We can do a get request, and we get back all of our orders. In this case, it's just one. So yeah, that one works. The next one, and pretty much the final endpoint, is getting an individual order. Now we can do what we've been doing before. So we can say func, and then we'll create a function that will find an order based on the ID that you provide, which will be of type integer, and the order, which is a pointer to the model object, to the model struct. This will, of course, return an error. So we can say database.database.db.find, and then a pointer to order, where the ID equals whatever ID we pass in. We can say if the order.id equals 0, then we can just return errors .new order does not exist. If it does, however, we'll just return nil. So that's our find order. So now we can create a function or our endpoint to actually get an individual order, and say func get order, the context, so fiber.ctx, return an error. We have the ID and the error, which is c.params int, we want the ID. We get the order, so order and then models order. If the error does not equal nil, then we can just say, what do we have in products? Let's just copy this. So we'll say if there is an error, please ensure the ID is an integer. Then we'll do if error, and then we'll do the find order, and we'll say ID and pass in our order pointer here, and then error does not equal nil, and we can just return c.status of 400 JSON. We'll have error.error. Next, let's go ahead and get our user and product for our order. So var user models or user, var product models dot product, say database.database.db.first. So this is just a query for give me the user with the ID of whatever user referrer we have in the order. So we can just say ampersand user and then order dot user referrer. We can do the same for our product. So we can say product and then say product referrer. Oops. like so. We can create our response user and say create response user, throw in user. We'll create another one, so response product. We can say create response product, pass in the product. And then we can create our response order. So response order, create response order, and then pass in the order, the response user, and the response product. And then finally, we can just return it by saying return c.status and then 200.json and then response order. And there we have it. So back in our main.go, we can go ahead and do app.get /API and then orders and then the ID, so :ID, and then routes.get order. And that should be it. So as soon as it's finished building, let's go back. Let's do a get to that. So we'll say HTTP, I think it's down here, orders, and we'll say with the ID 1, send, we get it back. We try something else, we get order does not exist. 1 works. Let's create another order. So we'll say, what other products do we have? Send, we have MacBook. So let's say John Doe orders a MacBook. I think the ID is 3 there. Send. So now we have a MacBook. We can get the order of ID 2. Send. We have MacBook. And yeah, that's about it. I mean, you can definitely, of course, like feel free to build upon this, kind of change up the user's endpoint to show how many orders they've requested. But yeah, there's quite a bit of messing around you can do here, or maybe looking to validation. But this pretty much covers the basics of getting up and running with Fiber, the Golang web framework, with Gorm, so the Golang ORM. And yeah, how to kind of make use of creating a CRUD API and taking into account foreign keys, etc. But as of that, that's about it for this tutorial. The GitHub or the source code for this project is, of course, in a link in the description below. So feel free to mess around with that and just experiment with it. But other than that, if you enjoyed this video, please leave a like and also subscribe. It would mean a lot. But yeah, have a wonderful day, have a wonderful month and year. Stay healthy and stay safe, and I hope to see you in the next video.